Graham Webb, VP of essentially GTF at Pratt Whitney. Thank you for speaking with me. So it seems the GTF has had a few hiccups, but it seems to be moving through, and for example, the problems at Indigo are now identified. Any thoughts on that?
Well, I'd have to say that, as you've indicated, we're continuing to work and invest heavily in curing some of the initial issues that were discovered during EIS. And we have now identified fixes which we're now implementing into both new production as well as in terms of our MRO returns. And all of those are continuing to improve the overall reliability of the GTF engines, which is, I would say, really the only key issue, because the fuel burn is fantastic, the environmental impact is great, and the customers, and I just talked to a bunch of Air Canada pilots, and they're all really excited about the experience that they just had flying their new A220 around, and also commenting on the really significant savings in fuel burn that these geared turbofan engines have been delivering for them in their first initial sorties. Now, as for me, these A220 engines were developed and certified here in Canada, built up in our facility in Mirabel, where we've made a fairly significant investment in both manufacturing technology as well as our flight test center, which did all the validation testing of the engines for both our A320neo engine as well as the engines for the A220. And so it's really a great pleasure to have this EIS event here in Canada with the Canadian Air Canada flag carrier.
So one of the things that was interesting, recently we had the Air Baltic taking delivery of the 100th A220.
Yes.
And the CEO of Air Baltic is a major fan of the airplane and the engine, and he pointed out that probably the next big thing in engines would be hybrid electric, but that the GTF is probably the pinnacle of the technology. What more can Pratt & Whitney do with the current technology to expand the great fuel burn, the low noise, the low pollution?
Well, in our case, we continue to work on the fundamental aspects of the geared architecture, which is really driven by two major components: the fan, which provides extensive savings due to the low speed that it has, as well as the low pressure turbine, which is high speed. And then in addition, we're going to continue to work on our core technologies. We'll infuse improvements in aerodynamics as well as materials technology, and those will be infused over time into the engines as we continue to grow and evolve, as well as what we see the rest of the market decides to do, all the other airframers, as we adapt this technology for those new applications.
Can you tell us anything about changing the gear ratios?
Well, the gear ratios would have to be adapted depending upon the bypass ratio, the size of the fan relative to the core. And so that's just a natural evolution of how we would adapt the architecture depending on the specific requirements that the airframers would provide us.
Thank you so much.
Thank you.